major thought leaders, those who have contributed not only financially but also intellectual contribution of Philips, Light Source Solutions from GE, Gerard Lighting, Silver Springs and Cisco. Each of these have played a significant role in guiding and developing the SLSC program. The next slide shows you the wide range of technical advisory group supporters that we have. These are the tags, and all of those companies should become very familiar to you as you move down the path of both lighting and control systems. These are worldwide companies in most cases that have committed to the SLSC program and IPWEA and are committed to providing their IP to ensure that what we deliver is contemporary and best practice for the industry. Thank you, Brian. The two documents, the model specification for lighting was principally authored by Graham Moore, and the control specification has been principally authored by Brian King in New Zealand. It's my pleasure now to hand over to Brian to take you through what the model specification on controls looks like, how to use it. We appreciate that it's a complex area, and the document has been written in a manner that allows you to walk through on an education type basis and also to make options and selections together with recommendations that have been included from our expert panel. From all of the input that we've received on both specifications, we have had only accolades and compliments. And I think on that basis, I'd like to publicly acknowledge the work that both Graham, Brian, and Godfrey Bridger, as the third part of the team, have contributed to the development of these groundbreaking model specifications. Thank you for joining us, and I'll hand you over to Brian.
Thank you very much, Robert, for that introduction, and welcome to the webinar. The structure of today, the agenda of today's webinar is going to be, as you see in front of you, we're going to do a quick refresher on the purpose and the benefits of the model spec, how we convert a model specification into a customized specification, talk a bit about the structure, but because it's a complex and large document, or a detailed document, I should say, we're going to focus on 6 key discussion topics. And of the consultation that we've been through over the last 3 to 4 months, these are the items that came up as being the hot topics that were caused debate and most interest. We're then going to talk about the next steps, where to from here with the model spec, and then hopefully have some vibrant Q&A to follow. So the purpose and the benefits, both LED, luminaire, and the control spec. Essentially, these what you see in front of you: save money, lower the risk, better technical outcomes, and to encourage greater competition among suppliers to give a better deal for those on the buying side, and better business opportunities for those on the supply side. So it's harmonized with technical standards, local and international industry norms, and we're very conscious of being in sync with industry best practice, but at the practical level. Trying to avoid reinventing the wheel and make sure that the specification is functionally written and is appropriate for both the supply side and on the buying side. So essentially, probity needs are important for public sector investment and procurement decisions, but it's a point to note is that's not a usable specification until it's customized for user needs, and that's a key point. It's about tailoring a specification from a model specification to suit the exact user needs of your project, your area, your community, and the outcomes that you require if you are on the procurement side. Objectives of the model spec. Help users select an optimal approach customized for the application. It's not just something that's one size fits all. It's about tailoring a fit for purpose to meet the outcomes that you require. Provide structured requirements. So the level of detail required is appropriate, so apples for apples comparisons can actually be generated. An important point is that the specification, the core requirements, which are presented as givens, that's usually because of standards requirements or regulatory requirements, but there is a lot of optional requirements listed as options and with guidance appropriate to guide users through. So, and warranty requirement important, we suggest reasonable minimums, and the supporting documentation is only required at the later stage. Initially, we are attempting to minimize the burden for respondents to tender processes, because we certainly realize that there's a good deal of supplier fatigue out there in terms of responding with a lot of effort to specifications which may not have been terribly well conceived. So support innovation, absolutely. It's not about having prescribed options which may second guess what suppliers are capable of delivering, and the structure of the model spec is about outcomes. It's about openly requiring, it's about openly identifying what outcomes are required and then letting innovative industry parties show how their technology and engineering can deliver best on those outcomes. And of course, it's life cycle based outcomes. It's not about who's cheapest on day one, it's about who provides best value over the life of the asset. And finally, it's designed to work hand in hand with the LED model specification. There is some overlap, particularly with the controls physical devices, sockets, connectors, and plug-in devices, etc. So we certainly have borne that in mind. So how do we go about converting the model specification into a customized specification? The document's divided into a number of sections in terms of action points. Firstly, the burgundy boxes are about explanations about what is behind the aspects of the specification items. These are designed to be removed and eliminated when and they are to be removed. The blue items are the action points. They are the instructions about what to do and how to do that. And the green options, green aspects of text are options for enabling a range of choices according to the requirements of the buyers and their needs. And they're designed to accommodate large urban councils, for example, right the way through to smaller rural type councils or DMSPs. In other words, there are a lot of options there. There are a range of items which won't be suitable for all parties, and that is indeed the intention. A list of options for you to then tailor to the needs as you require as a user. So the document can end up as straightforward and simple, or as extensive and advanced as you require. Structure of the model spec is as we see in front of us. A bit of an introductory and some notes there which just describe and set the scene with the background terminology and some diagrams showing how the pieces fit together. Information for tenderers is on the tendering and supply and procurement side about how the tender process is structured for controls. And bear in mind that we're speaking about an ICT product here. We're speaking about a system of parts working together. It's not a product like a luminaire, which might be a piece of hardware. This is a somewhat complex range of items, software, hardware, field devices, and the like, all coming together. And we certainly need to describe how those pieces go together before we actually go out to tender. Item 4 in the specifications, it's really a shopping list. And that's the detailed engine room of the specification. And these highlight in detail the questions and the requirements and the outcomes required by the tendering party. Won't go through all of those now. They're detailed, and they need to be detailed in order to make sure that the responses coming back are comparable, apples with apples, to ensure that the buying party can actually compare the value they're getting on a blow-by-blow basis to make sure that the functionalities are indeed comparable. Appendices might sound like the boring part of any document or specification, but there's some important points to note here. Terms and definitions. Well, because this is an emerging aspect of technical criteria and asset management, there's still not really a well-defined list of terms and definitions. And internationally, there are differences. There are similar terms used for the same subject, and people find themselves speaking about the same thing, speaking about using the same names, but in fact they're speaking about different aspects. So what we've tried to do is pull together an appropriate list of terms and definitions tailored to the Australian New Zealand market, and to nail that down so we're all on the same page as to what we're speaking about. Another item in the appendices are lists and definitions of existing luminaires and network devices, because there are already a number of councils and DNSPs procuring controls-ready luminaires, and for the specification to know what it needs to, the tenderers need to know what they need to interface with. There's got to be some sort of structured documentation saying what might already be out there. And also network devices. There are other aspects of city services such as traffic monitoring, people, pedestrian counting, temperature, environmental monitoring, sensors which are already out there, and some of those may need to network with the controls, the light and control specification, so we capture that. And finally, the returnable schedules are tables for easy answers with defined metrics and measures to make it easy for tenderers to respond and to quickly and effectively respond to our procurement process, and also for the evaluators of that process to compare apples with apples. So we've got 6 discussion points to run through, and this is the first, the overall system description. And this diagram really brings together what lighting control systems could look like. And the main things to determine from this diagram, we've got 3 layers horizontally. The central management system at the top, which is essentially the software, the server, and the field device, the interface devices that we're working with. In the middle, we have the network communications infrastructure, the comms, how the devices talk to each other. And finally, at the bottom, we've got the luminaires out there in the field on lighting poles and with various devices plugged into them in some way. So it's important to understand that there are these 3 layers, because when it comes to procurement aspects, in some cases, it may be appropriate to procure on a 3-level basis. Looking vertically here, we have 4 columns and 4 aspects of technology: power line, star networks with radio frequency, mesh networks with radio frequency, and cellular networks. So we're going to describe very shortly the different technologies and suppliers which are involved in these areas, but essentially this describes the sort of layouts and overall architecture that comprise lighting control systems. So discussion topic 2, we have a range of control suppliers here who are active in the Australian and New Zealand markets. This is just a general indicator, and it's a changing landscape and things move over time, but this gives us a quick overview of what the landscape looks like. If you look down the left-hand side, we've got the different technology platforms as far as communications are concerned: power line, radio frequency with star networks, radio frequency with mesh networks, cellular, and hybrids. And essentially, we put the logos here of the various companies operating in our markets, just to sort of show where the center of gravity of activity happens to be. And as is evident, mesh networks seem to be where most suppliers are gravitating towards. Now, this is a moving landscape, and it's not about pigeonholes entirely. Some suppliers straddle the different technology platforms, and as shown by the last line, hybrids. Some suppliers are actually taking what could be called the best of both worlds from various platforms and combining them into the different solutions. So as offerings. So that's a general indicator of how the supplier landscape looks in Australia and New Zealand, and it is a vibrant marketplace. There are certainly companies who are very much invested in this market and are keen to respond to buyer procurement processes. So there might be some questions. Might be a good time for questions to start with to keep things rolling. I'm struggling to find my my Q&A here, so just see if I can pull the questions down on my screen. I'm not having any success, so I'll move on at the moment.
Brian,
yes. I can't see.
Did you hear me?
Yes, carry on, Godfrey. Yes.
Scott Holland from Brisbane has asked a question: how do I choose between which communication is appropriate approach to use?
Which one to use? Which ones to choose? Well, that's a good question, and the answer, if you're on the procurement side, the answer is you shouldn't need to choose. The way that the model specification is structured is to define the outcomes required for the procurement entity. In other words, what are you looking for? What outcomes are you trying to achieve? Go out to tender on that basis and let the supply companies who have extensive R&D teams, engineering and technology background, come back with responses of what they think are likely to be the best technology or technologies to deliver on those outcomes. So if you as a buyer are scratching your head saying, this looks very confusing and I don't really understand it enough to go out to tender, the essence of the structure of our model specification is to say you don't need to do this, but rather to actually let the suppliers come back, let them put their best foot forward and say what's best in their eyes to meet your needs as a buyer. And then as a buyer, you will evaluate the value for money over time and make a decision on that basis. So any more questions at this point, colleagues? No? Okay.
There's another there. There was two more.
Okay, I can't see those, Godfrey. Could you dictate them for me, please?
Graham's asked, what communication approaches have the big deployments used to date?
What have they used to date? Well, there is, in our part of the world, Australasia, Auckland Transport is the largest by some distance. They have used long-range STAR radio frequency, and that suited the topography and nature of the Auckland landscape, geographic landscape, as well as the nature of the urban, the council region. So that was a selection there, and there are a range of pros and cons with each technology platform. Mesh is generally regarded as providing more suitable approach when in CBD areas with high density of urban buildings and the like, and high density of assets such as sensors and luminaires. And in terms of other large applications that come to mind, City of Los Angeles, for one, have gone with cellular networks, and the likes of Georgia Power in the States, which is probably the largest deployment worldwide, has gone for a combination of suppliers. I think there was three suppliers there with a combination of long range STAR radio frequency and mesh radio frequency. So it's not a binary choice. It's not, do I go one way or the other? There may be systems running interactively, or it may be hybrid systems, depending on conditions and the outcomes required. Okay.
Brian, there's a couple more comments being made. I'll dictate one from Lucas Jordan of Philips Lighting. This is an observation. Plans to refer, presumably meaning Philips plans to reference recent requirements from Critical Infrastructure Center relating to data management and storage, data policies, cloud services, etc. And after that, Davy Porkrell has asked, what are the common software as part of communication systems? What are the common software? What are the common software packages, I suppose, as part of the common system, communication system? Which suppliers amongst these suppliers supply the software? It's quite an involved question to answer.
Okay, coming to Lucas's question first, cloud service. There is a dichotomy of thought on the software service provision. Is it appropriate? Is it most appropriate to use a cloud service approach, where the buyer buys software as a service, or is it appropriate to actually purchase servers and software and run them within your own premises? And there's no real right or wrong answer to that. It depends on the approach of the procuring party, whether you run a lot of software yourself at the moment, whether you own the servers, run them, and have the staff required to do that. That would be a big impact on that choice. But I think it's fair to say that there is increasing tendency towards cloud serviced provision of the CMS, Central Management System software. And coming back to the next question from that, what is the common software that comes with that? Well, there is a dominant brand, and it's been evolving over the last 10 years in Europe. And that was originally Streetlight Vision, now owned by Silver Springs Networks, and that is a powerful player in the field. There are others, and it comes down to about where the critical mass is of projects, and the ability to actually purchase the three levels: central management system software at the top level, communication systems in the middle, and field devices in the out as a third layer, is dependent on the business models chosen, and we're coming to that in the next couple of slides. So I better push on with the presentation. So the next is about that item: modular procurement versus turnkey procurement. This is a critical the division in thinking in procurement approach, and I'll start off by saying there are no rights or wrongs here. It's about what the organization wishes to achieve. It's about what the flavor of the procuring organization is, depending on what's right for you. So modular procurement is the ability to procure a system in its parts and its components in three layers: central management system, network communications, and field devices, with potentially multiple suppliers competing for those various layers over time. This approach depends on the interoperability of components, and that's a key item. And this gives the ability for a procuring party to have competitive tensions, where the suppliers have to re-tender, let's say every 3, 4, 5, 6 years, whatever it is, let's say for software licenses or for communications licenses or for such like. So that's one approach, and that means buying the parts from different suppliers and the procuring party working with different suppliers at different levels. The other side is the converse of that: turnkey procurement, and which really means a single source supply contract for all of those three system layers. And to use the Apple term, this is about end-to-end functionality with responsibility for an outcome, with one party responsible for that outcome. And generally this means a partnering approach between the supplier and the user, and where they work together to deliver on the outcomes and as part of an overall package. And a point to note, and last line there, this could be CapEx or OpEx business models. This approach provides for a good deal of innovation in the supply, in the business models. It could be plain vanilla capital acquisition, same as other types of asset acquisitions, or it could be some sort of outsourced model, such as lighting as a service, network as a service, or the various approaches such as public-private partnerships, energy service contracts, or energy performance contracts. So what is best? What are the differences between them? The differences are quite stark, and it depends on the approach that the procuring party uses in other areas. And each of these approaches has strong advocates and others who dislike them. But in general, the turnkey procurement approach generally is for larger projects. To get critical mass for a PPP or an ESCO generally needs to be quite a sizable project to make the procurement process cost effective. And the smaller projects, probably the modular might be more appropriate. But as I said earlier, it's not about rights or wrongs, good or bad. It's about what is the best fit for your organization, your culture, your resources that you might have, and how that works together with other aspects of smart cities that you may already have underway. So, item 4, the central management system. This is the software that drives smart control system. And this is the key to interoperability. And generally what we mean by system software, what we've got in front of these 3 layers in front of us. It's about the workstations, how we host and store the software and the data, what sort of dashboards we set up to operate our systems, and the various aspects of communications compliant, ICT security, how we commission and set up the system, collect data, and how we actually specify the various aspects of lighting control that we want. In terms of the model spec, it's effectively, this is the detailed engine room of the model specification. There's lots of detail in there, and there needs to be lots of detail in there. During the consultation phase, some of the respondents said, gee, this is pretty extensive. Does it need to be this long? Does it need to be this complex? And the answer to that question is it does and it doesn't. It does if you want if you have a large and sophisticated requirements. You certainly need almost all of the aspects that we've covered. If you're a smaller organization and want something simpler, it's up to you as a customizer of the model specification to tailor it to your needs. So it's not about saying this is long and complex. It's about giving a wide range of options, structured options for the buyers to tailor to their needs. So essentially the software, the engine room of the specification is a list of very detailed Q&A type subject matter. But the overriding aspect here is interoperability. The central management system software really needs to be able to work. If you're looking on the 3-layer approach, the software needs to be able to work with a range of communication devices and a range of field devices. And what has emerged is a handful of industry consortia. Probably the most well-known is TELC, the TELC Consortium, which is about interoperability at the user level. Another is Lonmark for power line controls. Another one called the Open Smart Cities Protocol, which is an emergent one. And the DALI organization, which has been around for some time, is actually changing to a new consortia called the Digital Illumination Interface Alliance. And Zaga is one which is will be cropping up more and more. It's a long-standing organisation for LED lighting of all descriptions, but really only just coming onto the radar screen for outdoor lighting controls. I see a question that's popped up in the chat from David Sucker from Stowe in Queensland, and he asks, do you envisage that there may be a standard for control systems, or will they remain proprietary and left with manufacturers? That is the burning question, David. And I think the answer to that will be, in time, there is likely to be a small selection of dominant approaches. And will there be one singular approach? Probably not, because what we have to consider here with controls and communications is the need to actually contend with different topographies, geographies of cities and regions, and different needs, different data needs. What are you trying to do? Some will need high bandwidth, some will need low bandwidth, etc., etc. So it's likely that there will remain for probably in perpetuity a horses for courses approach, but there's likely to be a coalescing of suppliers and options into a whole lot fewer options than there are now, and the pathway is likely to be clearer than it is now. But it's a moving feast of options, and it's not quite clear how things will emerge in the longer run. So,
before you move on, there's about 4 other questions above David Sucker's that.
Okay, let me go back to those. Yes, I can see them here now. Franz Pluge, how long do CMS systems last relative to luminaires at 15 to 20 years? Well, as Franz mentions, 15 to 20 years is typically what the expectation is for luminaires of all technologies in the marketplace, more like 20 than 15. And do we expect CMS systems to last that long? I guess the answer to that is, how long do you want them to last for? And if a buyer wanted a 20-year life, I'm sure that suppliers could deliver on that, albeit with maybe some modifications to the components within in terms of upgrading them to deliver a longer life rather than a shorter life. The model spec has 3 options in there: 10, 15, and 20 years as elective options. And it's really up to the buyer to say, well, what do you want to, how long do you expect things you want it to last for? But bear this in mind. Think of our cell phones. Do people ask, when will my cell phone wear out? And the answer to that question is it might be 10 or 12 years. But typically what happens is after 3, 4, 5, 6 years, we say to ourselves, gee, there's a whole lot of new functions out there that my old cell phone doesn't have and I'd like them, so I'll trade it in and I'll upgrade. So it's not so much necessarily about technical or functional obsolescence, but it's about wanting to upgrade to more functionality when the cost benefit is seen to be there. So the jury's out, friends. We don't really know, but I suspect that most buyers will put something like 10, 15 years in there, but be careful what you ask for. Yes, I'm sure suppliers could deliver longer than that if that's what you wanted, but it's weighing up the cost benefit of those choices. Let's see. Question from Scott Holland of Brisbane City Council. Is there progress with the regulator in Australia for allowing CMS on unmetered networks? That's a complex question, and I don't have a simple answer to that. But what I do know, there is quite a lot of work happening behind the scenes with several organisations looking to break down the barriers, because that is indeed a barrier. At the moment, if one cannot monetize the energy savings that come from investing in smart controls, the return on investment looks a bit is undermined. So it's an important issue, and it is still work in progress, but there are some significant barriers that remain. but I believe it's one of IPWEA's aspects to target in the near future. So work in progress, watch this space, and hopefully there will be some progress on that important matter in the not too distant future. All right, our final discussion point, luminaire power supplies and interface options. This is quite a point of change and progression. We've listed in the model specification 4 options for intra-luminaire communications. By that we mean how the components within the luminaire talk to each other. And there are a number of options that could be elected. We've listed 4 as options in the model spec, allowing the options to be elected or not, as the case may be. The most common and well known, of course, is the analog approach, 0 to 10 volt DC, and that is the historic approach. DALI 1, as it's now called, has been around for some time in the interior commercial industrial lighting market, and it's only in recent times that it's coming to the fore in the exterior lighting market, but it's growing at quite some pace. DALI as an organization is moving on. As mentioned before, there is a new stewardship organization called the DIIA, and their website has some amazingly good information about the features and benefits of DALI, so I would recommend you look at that. And it's moving towards what's being known as DALI 2, which has a range of asset management features that DALI 1 does not have. We've put in here as DALI 2 as the recommended option. That's one of the very few things that we're actually taking a stand on and saying this is the way you should be looking. So that's an aspect that we would like to underscore. And also we put in there as an emergent option an item called Zaga Book 18. The Zaga consortium has been around for probably 8 or 9 years now, very well known for OEMs, original equipment manufacturers with LED luminaires across interior and exterior markets. It's not generally known to users, so it's a new concept coming through. But Zaga is an independent industry consortium, and they've come out with what they call Book 18, which is a power supply approach with receptacles as an emerging option. As we show above in those options 1, 2, and 3, we speak about the NEMA ANSI 7-pin approach. That's what I've got in my hand at the moment. We've got the receptacle, which is the 7-pin receptacle, which goes onto a luminaire, and into it we plug in a device, which is the actual outdoor lighting controller, and they plug in together and provide the interface between the luminaire with the receptacle and the control system with the plug-in devices, which go generally on top of the luminaire, sometimes underneath. So that's where we're at the moment. That's the approach which is being rolled out in large-scale projects worldwide. But we are moving towards, or the industry is moving towards, the Zaga approach, which is this device here. There is the receptacle. Here is an example of one of the control options which plug in, much smaller, cheaper, allegedly, or supposedly to date, and simplifies the actual internal wiring within the luminaire. So we are not promoting that as drafters of the specification, but we are highlighting that it is an emerging option, and it's with a view to keeping an eye on that, because the idea of these Zaga controllers, Book 18 receptacles, is that sensors go into these, not just control systems, devices, and there may be more than one of these on a luminaire, so keep an eye on that. So finally, in this aspect, a refresher on controls functionality. Why do we want lighting controls in the public lighting arena? Most people think it's about dimming, isn't it? Well, the answer to that is not necessarily. That may be appropriate for some areas of application, but not all. And it's worth noting that almost all of the large American rollouts are not about dimming. It's about trimming, optimizing, operating timing, reducing overlighting, extending asset management life, and a final shot on this slide about DALI, extensive commissioning advantages, two-way communications, and asset management benefits for users. There will be some more information on the SLSC website coming up about DALI and its uses, and it could mean, if adopted, some productivity benefits in terms of rolling out a deployment and operating and managing that. So let's just look at some questions here. We have one from Aprana Ashwin. We do have smart controls on roads leading to the airport, but in residential suburbs. Sorry, I didn't quite get that.
Brian, you have to go earlier, back to his first question.
Right, yes, I've got that, sorry. Are there any councils who have adopted smart lighting for newer suburbs and developments? We know from the research done by the IPWA SLSC program, a survey was done to both DNSP networks in Australia and to suppliers, and exactly 21 trials and pilot projects are underway. So not sure of the full-blown projects are out there, but I think the City of Ryde in New South Wales are probably a leader in this area. But please put your hand up if you are doing good stuff in your areas as well. So where does this take us? What are the next steps with the model specification? It's just been launched, as we've heard, and hopefully you've downloaded. It's free, and some of the major cities in Australasia have indicated a desire very quickly to adopt the model specification for their options, for their proposals right now. And APRIA will evaluate the demand for training as to what levels of training might be required to fill in the gaps. But bear in mind that model specifications are living documents. They need regular periodic updates. It's a moving target. It's not about a snapshot saying this is where things are at and will be so for the next X years. It's about evolving with the changing technology developments from suppliers and changing needs of the procurement parties. So it's essential that you participate to help improve this documentation, whether you're a buyer or a seller or a consultant or a contractor. Please do participate and say what you like or don't like about the model spec as it evolves, and its value in the marketplace, the momentum that it generates, will really only come from adoption by users and the ability to improve it as time goes on. So that's the presentation as such. We move on to
Brian, can I just ask, there was a question earlier on by Murray and Natasha wanting to know if these slides were available, and of course they will be, won't they?
Yes, indeed they will be. There'll be a recording of and of the slides will be available on the SLSC website in due course, which hopefully isn't too far away. So yes. And which brings us on to general questions and comments. So we welcome your commentary, please.
There's one from Franz.
Okay, Franz Plush, I see that. What do you say to the argument that you can install the LED now with the socket and install the controls at a later stage? Well, it's about economics. The question that Franz makes is a very real one. How much does it cost to get to, if you don't install the controls when you roll out a luminaire, an LED luminaire upgrade, what is the cost of that? The answer is very clear cut. It's what is the cost of going back at some later stage, 1, 2, or 3 years hence, to actually then plug in the device, the actual light point controller, get it up at 7, 9 meters up, and then plug it in and say, hey, we've got controls now. And typically that's, from most councils and DNSPs that we talk to, around about $140, $150 to do that. So immediately what is being, let's say, wasted, if I can use that rather emotive term initially, is that if a procuring and implementing party doesn't go ahead with the combined LED luminaire and control system implementation at the same time, you're throwing away approximately $150 into the ether that could well be used to actually generate savings of energy and revenues as time goes on. So it's a very clear-cut question. Why, if it's the business case shows that there is a case to go with controls now, and there is a return on investment, waiting simply leaves money on the table and potentially squanders some of the savings that might be possible. And the savings are not just monetary, they're carbon, they're energy, they are light pollution, etc., etc. And I think it's a well-known subject now that Auckland Transport, who've rolling out 44,000 combination project, made an early decision when they did their cost-benefit analysis that was, it just made good sense to roll out the two both at the same time. But of course, it's a matter of each case on its merits, but that's really a fairly clear guideline forward. I see another question from Ashish Anand. There is a lot of knowledge sharing needed to get to a point of sale with customers looking for smart lighting. What would be the pain points and which are the most important and needs to be addressed? So Ashish is talking about knowledge sharing to get to a point of sale with customers looking for smart lighting. I guess as procuring parties, be they DNSPs or councils, to have comfort going forward that they are not walking into an abyss or a black hole or whatever, there is a lot of comfort to be had from shared experiences and pooling of knowledge, good, bad, and ugly. And when it's good, let's do more of it. When it's not so good, let's know what's not so good so we can steer a pathway forward. So I believe that the IPUIA approach with the Street Lighting and Smart Controls program is about sharing information. It's about a non-partisan, non-commercial platform for sharing the experiences of these rollouts. So Ashish, I would say keep watching the SLSC website, and that pooled knowledge as it comes in will certainly be logged into that portal for general access and learnings. I see a question from Adam. I understand that some lighting companies are now supplying lights with the 7-pin as standard. Yes, Adam, that's my understanding as well. And I would even go a little bit further than that by saying that it's become almost universal. Some of the larger procuring parties, DNSPs, councils and road controlling authorities have in their own specifications that they've developed over the last few years this as a mandatory requirement. The NEMA ANSI device, 7-pin as standard, NZTA for one, and I know that some of the road controlling authorities around Australia are doing the same thing. So yes, that's certainly a fair thing to say. Scott Holland has said that would be the 7-pin base, and my answer to that is yes, that's my understanding also. Question from Amish Sheth. For local governments only just starting, how small should a project size to strap the transition to smart controls? I think what Amish is asking, are small projects valid to start? Sorry. Yes. What is the requirement? Is there a critical mass to step into before going forward with controls? And the short answer is yes. Yes, there is. Where exactly it lies is the moot point. Being able to set up the overarching, let's say the ICT backroom to run controls, which is the CMS, central management software, the communication networks, the base stations, and the the communication devices, there is a certain entry level for that. I wouldn't really be comfortable putting a figure on that, how many units, how many how many light points that might be. I guess it would be in thousands. I think anything less than that as a standalone, the cost per unit would probably be getting quite high. And like many aspects of commercial life, it is an economies of scale issue. It's a bit of you need to step into a certain entry level quantity, and then it becomes a marginal costing exercise from there, where the more units you add on become quite moderate in terms of the add-on costs. So yeah, but on a more constructive and positive note, the idea of councils and or DNSPs getting together into coalitions of smaller groups to create critical mass is certainly what's happened overseas, and various local government associations and their kindred spirits are doing that and smoothing the costs of acquisition, of advice, and of implementation and rollout to create, excellent real-world economics. So get together is the answer, Anish. If you're a small organization, find some buddies with your councils in your area and create some critical mass from there. I see a question from Adam. In Victoria, the power supply companies have a CMS in place as part of their smart power meter supply. Can you pay to access, oops, the question's disappeared from my screen. Can you pay to access, for council lights? Not quite sure what that question means, but the idea of coalescing together of different needs for smart cities, be it water metering, be it electricity metering, be it traffic monitoring, and tossing that information into the cloud, they are distinct possibilities to go forward with. So, yep, access is possible in theory. The practicalities are according to each of those organizations. It's pretty much, time is rolling on, so need to wrap up, but I see a last question here. DNSPs, distribution network service providers. So, excuse me, I've just gone a bit out of sequence. And
so that was just me trying to describe what DNSP meant, that's all.
Sorry, I didn't clarify that. So it's time to wrap up. Thank you very much for attending, and a sincerest thank you to the Australian Government Department of Environment and Energy for being a staunch and loyal supporter of this program, and also to the SLSC Council and Technical Advisory Group. Those companies have provided massive input, and speaking specifically about this smart controls model specification, there has been a number of control suppliers that have helped knock this spec into shape, knock off the rough edges, the theoretical aspects that might have been in there earlier on, to make it a truly reflective industry reflective document. So thank you all. So on that note, we shall wind up and catch you again at another SLSC webinar, we hope. Thank you.